Nothing will drain fun and joy from your model railroad as much as frequent derailments. Over time, it's just going to lead to frustration, dissatisfaction, and for some people may even abandon their effort or even get out of the hobby. However, derailments are all preventable. So in this video, I'm going to cover 10 common derailment sources and how you can fix them or prevent them. The first source is a offset joiner, and this typically occurs when this diagram is when you put the rail joiner on one rail and you push the tracks together and you think they go together, but what actually happens is that the rail joiner does not engage the other rail and runs underneath the rail. And the track may actually look fine, and especially if you're putting track together, maybe you're having to lean a bit, you're a couple feet away, it's not right up in front. You won't necessarily won't notice that. And of course, if you don't notice it when you're doing your testing, it's like that, your trains are going to find this and more likely derail. So we have like the example of these two pieces of flex track where I've created this problem. You can see kind of twisting this together here. This rail is not attached. This typically happens. Now, of course, how you can address this is for each joint you make is run your finger across the joint. If it's have an offset problem, that offset joint is going to snag your finger. You are going to feel it. So want to make sure, then fix that. Then you want to do is fix that issue. Also, for any joints, we want to make sure as you run your finger across the joint, it needs to really be able to feel as smooth as glass. And if you do feel some sort of irregularity, take a file and just file across the joint at an angle. So you want to until you get it feels nice. When it feels nice and smooth, because any irregularity doesn't necessarily have to be an offset joiner like this, where it's really out of the rail joiner, but any little bump in here can actually cause a wheel set to pop and then eventually cause a derailment. The second item are joint kinks, and this usually happens when, again, this can happen when either can happen in a couple spots when you're putting sections of track together. You can actually, especially with flex track, you can create a situation where one joint is the rail is running straight, it's not really bending straight, and it creates a kink. Or you might have a piece of track off a switch, as an example. And this is going to happen with sectional track as well. So just because it's free flowing with the flex doesn't mean it's not going to happen with sectional. Especially and of course, addressing this with flex track, what we wanted to make sure is that before you bend your flex track, solder these rail joints line them up straight, then solder them. And once they're soldered, then bent. It also helps to do is remove only the minimal amount of ties. So typically, that's usually in case it's about 2 ties. Any more than that could create a situation that this rail may go out of gauge. So we don't want to. You only want to take the smallest amount of ties that you can off the track. Now, of course, to note with kinks, you want to be able to do, and this is why also it's good why you don't want to have reach too far when laying track. Is basically use your eye, and if you can, sight down the rail. If you see any kinks in there, they'll be obvious from your eyesight. So then you should be able to see a kink. You can then adjust the track while you're laying it before you finally fasten it down. The third area is the case of uneven roadbed, and this is the case of construction we're doing with cork, and we're going to go out to the layout room to show what the issue is on that topic. As you lay down your cork roadbed, we want to make sure that when you're done laying all your pieces, we want to make sure that all the roadbed is nice and smooth. And this is especially a concern around switches, where you may be adding a lot of pieces to fill in the appropriate locations where the tracks cross between one track and another. There's a lot of diagonal pieces, filler pieces. And what we'll want to do is make sure this nice and smooth before you lay the track. Any bumps in here because you went over, maybe there's a flaw in the wood, or maybe it's on top of a screw that wasn't quite all the way sunk down, a slight mismatch in the cork for some reason, could cause a hump or a twist in your track, and could be a derailment problem that you may not notice until many later when you start running trains and you can't figure out what the actual issue is. You want to do when you lay, after you're finished laying cork, you want to take one of these small Stanley Surfform tools and especially feel where you potentially might have unevenness. Like for instance, I was kind of filling in track here and feel this little piece of cork in here, filling between the two tracks is actually a bit higher than the adjacent. So we want to take this and I want to just run it over the top and see now it's now nice and smooth, and it's smooth equal to the roadbed on each side. So you want to make sure to run this tool over all your roadbed as you lay it down, and make sure you're ready nice and smooth before you start adding track. The fourth topic is a inadequate vertical curve or inadequate vertical transition. If you have your grades, when you come up to a grade and it curves too tight, either at the top of the grade or at the bottom of the grade, especially nowadays with a lot of the locomotives today, diesels especially, the fuel tanks, the scale, there's not much distance between, say, the tops of the bottoms of the pilots or the fuel tanks to the rail. Something that is too steep is potentially, you could get a fuel tank strike as possibility if you don't have adequate adequate curve at the top of the grade, or you potentially have something that's too steep at the bottom of the grade. And then you could get a pilot to strike, or a coupler pin or something like that could actually strike. It's possible that this happens. So, and also most likely though in this case, what's going to most likely going to be happen is the cars will uncouple on the grade, because the transition is more than the height of the coupler, and the couples will pull apart under load. And of course, in that case, you could have a runaway, which might in some cases end up in a derailment, or worse, equipment on the floor. So for the inadequate for this vertical transition, this is one of those things that you will want to make sure make sure that your couplers line up straight, and you may have to adjust your bench work or your riser height, for instance, like that, to get these issues to smooth out. You may have to add shims under the roadbed or under the track, again, to prevent that from happening. So the only way you're going to test that, you're going to be testing when after you've constructed the track in these areas. The fifth area is S-curves, and this is a topic that has been covered before in other videos on my channel. I'm going to there's one up here on the screen here. But this is important. S-curves, again, this is one of those things that's more of a track planning issue. However, it can come up well in construction of your layout. And basically with S-curves, you want to make sure, if you do have an S-curve where it kind of has a reversing type curve, is that the straight section between the two S-curves needs to be equal to or longer than the longest equipment you're going to use. So this is the important. This is so because otherwise the car will tend to be, you could possibly, cars could be one end is bending away in one direction and one is bending in the other direction, and you have that combination going on especially on a long train. You can get derailments. The sixth area, what I would call, inadequate roadbed transition. Now, sometimes with real railroads, you'll have main line for drainage is usually elevated high. The sidings are usually have a lesser grade. In some modelers, they will take these, might say they're doing HO. They have the HO 1/4 inch high road bed. Then they transition to N scale road bed, which is only an 1/8 inch, or they might go all the way down to the foam or plywood surface. One thing is important, if you're going to do this kind of transition where the sidings are less than your main line on your road bed, you want to make sure that your turnouts themselves are flat. Do not start your transition, your grade, until you're outside of the turnout. If this turnout gets twisted, again, that could put enough pressure when your wheels like that could cause derailments. You want to hear any grades, you want to go down. Because again, this gets into an area, these areas here are already subject. You already have this, S-curve in here. You could have a uneven roadbed issue. There's that potential for a joint kink in here. So there's lots of areas that all come together that creating this issue. Now we're also going to have we're going to go back to the layout room, and we'll show here again how to do a check for and make sure your roadbed is nice and smooth when transitioning to these different areas. So if you're going to be adding transitions, either from a tall cork roadbed to a shorter cork roadbed, or in this case, like here, where we're going from a cork roadbed down to the base plywood, we want to make sure that we have a nice, good taper of the cork. So again, this is another application of the Surform tool. Is like on this cork ramp here. We want to make sure this has a nice taper. So we want to make sure that any of these locations, we want to basically make sure that cork is nicely ramped down. So when it gets on here smooth, so we don't create a vertical kink or a transition issue across this point. And also it's smooth enough that we bend it, slowly drops away from the turnout and is not affecting the turnout itself. The seventh type, now we're going to switch a bit and go on to equipment. And the second it will be low coupler pins, the uncoupling pins on your typical KD or microtrain knuckle coupler. We want to make sure that these things are appropriate height. If they're too low, they can actually snag parts of turnouts and things. And for that, want to make sure that you want to get your KD or microtrain's coupler gauge. And these are either plastic or metal. Then we'll have a coupler in the pin, so you can test for coupler height and pin height. So for testing coupler pin height, take your gauge, put it on your track. It could be a test track. What we want to do is make sure that the coupler pin slides above this shelf that's on that's on the gauge. It should just run right across the top of it. It shouldn't be too high, nor should it be too low. We push the two cars together, and we see, for example, this pin is just above the top of the gauge. So this pin should not strike anything, for example. Now, as a comparison, I have this flat car, and we put these cars together, and note in this case that the coupler pin on this one actually strikes the shelf of the gauge initially. It actually hits it. It actually hits it before it rides over the top of it. So in this case, there's a slight mismatch in this. And then what you're going to end up wanting to do is take a pair of needle nose pliers and hold the coupler, in your hand. You're going to end up having to twist that, bend up that pin slightly, as for example. Now, of course, it's not a problem with this car, but when you're doing your coupler pin heights, if you find that the problem is not the pin is low, is because the whole coupler head is low. This case usually will mean you're either going to have to add washers to the bolster. Like this car actually has washers on it. It was before the body was actually too low, such that in it being the pin would be too low. Or you may have to place a shim underneath the coupler box and lower the coupler. Both KD and Microtrains do sell these shims and washers that you can do these adjustments. So sometimes it's always just the pin. You can bend the pin. If your couplers are out of height mismatch substantially, you may have to address the actual coupler and mounting height. The eighth item is also about freight cars and ICE equipment in general, actually, is out of gauge wheel sets. If wheel sets are too narrow or too wide, that will inevitably cause problems on track, especially on turnouts. What we want to do is get one of these NMRA gauges. And this is an N scale gauge. They're available in O and available in HO from the NMRA, and also probably should be able to get them from most large hobby shops as well. And then from these, we can look at, they have a nice little gauge in here for wheel sets. And you want to do for your freight cars, when you put these cars on the layout, is make sure that these actually, the gauge of here, that the flanges fall nicely into the notches. And they should, and like this one does all the way. And this is plastic wheel sets. You can't really do much with these. If these are out of gauge, you'll have to replace the wheels. If you have metal wheels, usually with metal wheel sets, because there's a plastic bushing for insulation, usually you can twist them slightly, and you can narrow them up or widen them out as necessary. This is, again, you'll need to, if you have cars, especially a car that derails in multiple locations, it's probably the car. If you keep having multiple cars derail the same location, it's probably your track. The ninth portion, now we're going to get back to the track. Turnout frog and Flangeway slop. In your turnouts, it's possible that if the flangeways, being the stock rails and the guard rails, is too wide, you could get a lot of wheel set hunting. And then that could cause a wheel set to pick the frog point, which will inevitably cause a derailment. And generally, how we can fix this is you can add some fur strips, some thin styrene. This could be, like, depending on the scale, 5/1000s, 10/1000s, whatever is necessary to put some extra width on the guardrail. This will then allow pull the wheel set away from the frog point. And it should help prevent derailments. One thing you can test things again is go back to the NMRA gauge, and there is at the top of the gauge it says marked flangeways. You can take the gauge and put it on between the frog flangeways and test this and see how much slop there is between these points. And this one here doesn't have too much slop. You should be able to put it in here. You shouldn't have to force it in, nor should it be a lot of slop. The more slop you have, the worse it is. Now the last area, the 10th point, is uneven points. And typically, if you look at the top of a switch, regardless of scale, there'll be the top of the rail. There'll be each of the stock rails will be notched. For the point rail. So when the point rail is in place, it should be this point across here should be smooth across. Now, what happens is sometimes with a lot of manufacturers' turnouts, the notch may not be adequate enough, or more than likely, the point rail may be a little thick, or it doesn't quite throw all the way over enough, or some flaw. Sometimes this point rail gets down, it's pretty thin at this location. So it can be not quite smooth. If it's not quite smooth, the wheel set will likely pick this point and will cause a derailment. So we're looking at our switches again with our points. If we note that where this point rail comes into the turnout and doesn't, there's an uneven bump, you can take your file and just file the upper edge of that point rail kind of towards the rail, and since you're going to kind of file it so it kind of files it towards the stock rail, this will actually help those wheel sets from picking that point. Elsewise, you can also go in with some turnouts if that's not adequate enough. Is getting in with a thin file, flat file, and try to file where the location of where the notch is. So sometimes you can't address it here, you can address it here. This is a bit more difficult, especially. But if you can, try to file back this little edge. Again, you want like with the joints. Figure your finger should be nice and smooth across that location.